Welcome to this video. In this video, what we're going to focus on is the sine of an angle ratio. So by definition, the sine of an angle ratio is equal to the opposite length over the hypotenuse length, right? For example, this ratio is applied to only right angle triangles. So here I have an example of a right angle triangle, right? Now, let's say that the angle in focus here is theta, right? Which is this angle right here. Now, if I should label this side according to angle theta, what I would note is that opposite from the angle, if I draw a line going across, then this side would be what we call the opposite side, because it is opposite to the angle theta, which is in question. Now, we know that the hypotenuse is always the longest side on the right angle triangle, and it is always opposite to the 90-degree angle. So this side here is going to be the hypotenuse, all right? Which means that the side that is alongside the angle that helps to make the angle is what we call the adjacent, all right? All right. So that's it there. That's how you would label the sides of your right angle triangle. All right. The sine of an angle in a right angle triangle is the ratio of the opposite side to the hypotenuse side. Note that the sine of an angle ratio is used to calculate the length of an unknown side in a right angle triangle and the measure of an unknown angle in a right angle triangle. So what we're going to do, we are now going to look at how we use the sine of an angle ratio to calculate the length of an unknown side in a given right angle triangle, all right? So here, we are asked to find the length of the marked side, right? So as you can see here, we have a right angle triangle. Now, we have an angle which is 25 degrees. We have a side that is marked P, right? And we have another side which is 10. Now, we must use the sine ratio to determine the length of P. Now, the first thing that you would need to do is to label your triangle, right? So if we draw a line from this 90-degree angle here, going across like that towards where 10 is, that would take us to the longest side, which is going to be the hypotenuse, right? Now, when you look at the angle in question that is given, which is 25 degrees, if we draw a line from that angle going straight down, it will take us to this side, which P, where P is, and that would be the opposite, because this side is opposite to the angle. So therefore, we can use sine of an angle. So we know by definition that sine theta is equal to the opposite length divided by the hypotenuse length, right? Now from this formula, we can substitute what we have. We know what theta is. In this case, theta is 25 degrees. So it's going to be sine of 25 degrees is going to equal to the opposite length, which is P in this case, the unknown that we want to solve for, over the hypotenuse length, which is going to be 10. From here, it's just a matter of just using up your calculator. So you would put sine 25 on your calculator. When you do that, your expected value is going to be 0.423, which is going to equal to P over 10. In order to solve for P, note that this P is being divided by 10. So we can get rid of this 10 by multiplying both sides by 10, all right? So all we need to do at this stage is to multiply both sides by 10. So we're going to multiply this side by 10 and also multiply this side by 10, all right? So note here that when we multiply both sides by 10, 10 into 10, that will give us 1. And 1 times P will leave us back with P, right? And 10 times 0.423 will give us 4.23 meters, right? So now we are asked to find the length A here. So again, we are given a right angle triangle. The first thing and the best thing to do is to always label the triangle in terms of opposite, hypotenuse, and adjacent based on the given information. So the first thing that we're going to label here is our hypotenuse, because that is the longest side and it is always opposite to the 90 degrees angle. So where a meter is, we know that that length is the hypotenuse, right? Then now we have to look at the angle that is given. We have a 15 degrees angles here. So if we draw a straight line from the angle going straight across, it takes us to this side where 5 meter is. And we know that that's going to be the opposite, right? Because this side is directly in front of this 15 degrees. So it is opposite to it. We don't need to label the third side because we don't have any information for it, all right? So again, based on the information, the suitable ratio is going to be sine of an angle. So we know by definition, sine of an angle, which is sine theta, is equal to the opposite length over the hypotenuse length, right? Now it's all about substitution. What is theta in this case? It is given, that's 15 degrees. So it's going to be sine of 15 degrees is going to equal to the opposite length, that's given 2, that's us 5. All of that over A, which is what we want to find, all right? Want to determine what's the value of A. From here, it's just about punching sine 15 degrees on your calculator, right? And I would advise to use 3 significant figures. So when you punch in sine 15 on your calculator, that will give you 0.259. That's correct to 3 significant figures, all right? It's going to equal to 5 over A. From here now, note that the unknown that we want to find is in the denominator. So our first objective is how we can, is to transfer this unknown value, which is A, into the numerator. And we can do that by multiplying both sides by A, right? So we can multiply this side by A, and we can also multiply this side by A here. So by doing that, what we'll now have here on the left will end up with A times 0.259 is equal to A into A will give us 1 here. So what we're left back with is just 5, all right? From here now, we can make A the subject by just dividing both sides by 0.259, all right? So we're going to divide both sides by 0.259. All right, by doing that, that will take us to our solution, because clearly here you can see that 0.259 will divide 0.259, and that will just give us 1. So that leaves us back with A here is equal to 5 divided by 0.259, and that is going to give us 19.3 meters. So that's our final answer there. Now for this problem, we have a triangle, right? And we are asked to determine X and Y, which is the unknown here. And we are given all 3 angles inside of this triangle, and we are given a length, which is 13. Now, the first angle that we are going to focus on here is angle 60, right? So we're going to focus on angle 60. So if angle 60 is the focus, we're going to label the triangle according to angle 60. So let's label this triangle according to angle 60 here. So you note here, if I follow this straight line, where it takes me to where the length X is. So X is going to be the opposite right? And that's according to angle 60. Now here, the longest side is always opposite to the right angle triangle. So this side where 13 is, that's going to be the hypotenuse. Now, by just labeling this, we can now determine what x is by applying the sine ratio. Because what we know that sine of theta is equal to the opposite length divided by the hypotenuse length. Here, clearly, we can see that theta in this case is going to be 60. So it's going to be sine 60 degrees is equal to the opposite length here, which is going to be x, divided by the hypotenuse length, which is going to be 13 in this case. All right. All we need to do is to put sine 60 on our calculator. So if we put sine 60 on our calculator, what we'll get is that we'll get 0.866 equal to x over 13. From here, to get x by itself, which is what we want to find, we're going to multiply both sides by 13. All right, so we're going to multiply this side by 13. And we're also going to multiply this side by 13. By doing that, what you would realize is that 13 into 13 is 1, and 13 into this 13 will give us 1. So what we're left back with here is just x. And then 13 times 0.866 will give us a final value of 11.258 meters. All right. So that's how we'll determine the value of x. Now, to determine the value of y, the angle in focus will be the 30 degrees. So let's label this triangle according to the 30 degrees here. All right. So if I label this triangle according to the 30 degrees, note here that where this length y is, that's going to be the opposite. And the hypotenuse will remain the same. It won't change, right? So therefore, we can see that sine theta is going to equal to the opposite length divided by the hypotenuse length. Right? What's theta in this case? Theta in this case is going to be 30 degrees. So it's going to be sine of 30 degrees is going to equal to the opposite length, which is y. That's what we want to determine, over the hypotenuse length, which is 13. All you need to do is to put sine 30 on your calculator. When you do that, you will realize that sine 30 will just give us a half. As a decimal, that will be 0.5. It's going to equal to y all divided by 30. At this stage, to solve for y, all we'll need to do is to multiply both sides by 30. All right, so we're going to multiply this side by 13 and also multiply this side by 13 as well. All right, when we multiply both sides by 13, you would realize that 13 into 13 is 1, 13 into this 13 is 1. So what we left back with here is just y, because 1 times y will give us y, right? And 13 times 0.5, that will just give us 6.5 meters. And that's how we would use the sine ratio to find the length, the missing length of a given right angle triangle. Thank you very much for watching, and do enjoy the rest of your day.